Okay, because of the Zoom day, I'm going to go over chapter 2, multiple choice practice on a video. So you can have that help. Make sure if you have questions, you could text me. We could set up a Zoom time also. Um, but here we go. So you could watch the whole video or just whatever part you're stuck on. So 64th percentile is between the 50th and the 75th percentile, and the median is the 50th. The third quartile is the 75th percentile. So the answer to that would be C. Sorry, okay. Number 2, they're telling us the mean is 18, standard deviation is 6. So in this case, you're going to use the formula Z equals X minus mu over sigma. So basically, Z is that negative 0.7. That is the standardized score. So you're going to have negative 0.7 equals X minus 18, because that's the mean, over the standard deviation of 6, and you're going to solve that. So if they give you a question like this, use this formula. It does show up quite a bit. The rest I'll leave the algebra up to you. Okay, this one is a bit tedious, but we have, let's see, we have the X, we have the average, and we have the standard deviation. So if you wanted to get his z-score, you're going to do X minus the average over the standard deviation, and that's George. That's his z-score. It's really z. And Bill, same idea. You have 190. This is X minus the average over the standard deviation. That's Bill. Whichever one is bigger is going to give you the correct answer. That's the G and the B is really the z-scores. They tell you how many standard deviations above the mean each player was. Okay, next, number 4. So what's not changed? The standard deviation isn't changed, because just bringing everything up by 30 doesn't change how spread out they are. It might change the mean, the median, all those will change, but not how far away the scores are from the mean. Number 5, okay, so multiplying by 10, all of these are, except for the variance. The standard deviation is multiplied by 10, but remember that the variance is the square of the standard deviation, like that. So if the standard deviation is multiplied by 10, it would make sense the variance is not. It's multiplied by 100. Okay, number 6, nearly normal distribution. I honestly don't really agree entirely with this question. But they're saying that it's D, the family incomes are not going to be normally distributed. Maybe everybody who goes to the same school has similar incomes. I don't really necessarily agree with that, so I'm going to let that one go. Okay, number 7, point C on the normal curve. So if the mean is 80, that would be right here. If a standard deviation is 2, so C would be 78, because it's 1 standard deviation away. So that's just minus 2. And number 8 is what percent cockroaches have between 76 and 84. I would put this into the calculator. I like to do everything in the calculator. On the graphing calculator, the lower will be 76, and I think it's called upper is 84, and the mean and the standard deviation are given to you above. I don't remember them now. It's maybe 80 and 2, I think. And just put it in and let your calculator do the work for you. Same thing with number 9. It's the same idea, but the lower will be that negative 999, and the upper will be 78. And let the calculator do the work. I know that you can figure this out using the normal curve that you might have memorized, but it's not necessary. Okay, for number 10, also, this is just regular Z. So the lower will be negative 999, maybe that. The upper will be 1.15, but this time the mean will be 0, and the standard deviation will be 1. That's just your standard normal curve. And the answer will be given to you with a proportion. And number 11, so 11 depends on your calculator. But mostly you could just say that this time the lower, in the same normal in graphing calculator, the lower will be negative 0.75, and now the upper could be 999. And the same mean is 0 and standard deviation is 1. So that's just a standard normal curve. Okay, number 12, let's scroll. 73rd percentile is exactly E. It's just a definition. Being in the 73rd percentile means that you're better than about 73%. So that's just a definition. Okay, 13, the standard deviation. So here you kind of want to estimate it. So the mean is 2. Let's look at the choices. Let's say you chose C, the standard deviation would be 2. So if you do that, you're going to see that it's broken up into like a lot of segments, and that's not what our normal curve usually looks like. So that doesn't look good. But if the mean of 2, if you make the standard deviation of 4, so 2 plus 4 is 6, you'll be over here for your first standard deviation away. And you'll be at 10 and negative 6 for a second. And that looks approximately like what your normal curve usually looks like. So that would be D. Okay, 14. Rainwater collected. Okay, so for 14, for the mean, you just do what they say. You could add the 0.1 and multiply by 1.2. That's fine. The standard deviation, you don't ever add. You just do the multiplying. So you're just going to multiply the standard deviation by 1.2. Because remember that if you just add a certain amount to different numbers, that it doesn't change how far apart they are, how spread apart they are. It's the multiplying that actually changes that standard deviation. Okay, 15. So this is a cumulative percent graph. So let me see what's the question. What percent of adults are between 4 and 8 ounces? So 4 is right here. So you're at the 20th percentile, and 8 goes up here, so you're at the 60th percentile. So 60 minus 20 is 40. Because it's a cumulative percentile, then 20% are up to 4 ounces and 60% have up to 8 ounces. So you're going to see the difference between those two to see how many are between 4 and 8. Again, if I'm going too fast and you have questions, please text me. Number 16, the average normally distributed. Okay, so for this one, the 15%, first of all, exceeds. So that means that 15% of the time your value is higher than 60. So this 15% would be the top 15%. Right? So let's just put a curve. The mean is 55. And 60 will be somewhere, I don't know exactly where, 60. So 15% will be over here. So your first job is to do the inverse normal for this to get the z-score. And you would do the proportion that you're looking at is that 15%. You might want to do that proportion would be 85% really. That's probably the best way to do it, because your calculators, most of your calculators will only be doing the bottom half, the bottom part. So if the top is 15%, then you're really looking at the 85% to get your z-score. And you're going to get your z. I planned poorly and didn't put my calculator next to me, so I don't know what that's going to be. But whatever that is, you're going to make that equal to x minus the mean over the standard deviation. So that z that you got from your calculator, you're going to make it equal to 60 minus 55 over the standard deviation. And that's something that you'll algebraically be able to solve. Okay, so one more time, it's exceeding 60%, 60 inches, so you're the top 15%. Your calculator will most easily be able to handle the 85% because it's the lower part. And then you're going to use that same z formula that we've seen other times. Okay, let's look at number 17 for a second. So A is the minimum, G is the max. The median should split the area about in half, and I'm going to go with D for the median. And then from the median, then E seems like it might be the third quartile because it's kind of evenly split. And that's the median. So the first quartile, I don't think is really shown here, but I would go with C being the mean. C should be pulled to the left of the median. So if the median's at D, the mean should have been pretty impacted by the outliers. It's pulled to the left because you have some really small values in there. B is really nothing. B doesn't look like it makes sense for anything. So I didn't use F and I didn't use B. So the answer would be choice D. Right, the first quartile is somewhere else, not quite at B. Okay, number 18. Let's see, so if the distribution, the standard deviation. So again, if you have 99.7% between 5 and 7, then you'd want to use your inverse. Yeah, you probably want to use the inverse normal graph, but this time the 99.7 would be like the middle, would be somewhere like this between 5 and 7. The mean would be 6. So if you're going to use your inverse normal to find that, or you might have this memorized, but if you're going to do the inverse normal in your graph, you're going to do 1 minus 99.7, and you're going to divide that by 2 to get this area. And that's what you're going to put in as the proportion that you're looking for. So you do 1 minus 99.7, and then you're going to divide that by 2 to get what this 5 would be. And then that Z, that would give you a Z. And just like before, you'd say that Z equals, I guess, 5 minus 6 over the standard deviation, and that you could use a calculator, you could do algebra and solve that. Okay, 19, which is not correct about the standard normal distribution. So these you could just check with your graphing calculator. Really, either you have it memorized, but you can just put it in. So if you put it's up to you. You could put the inverse normal of that number and see is it equal to -3 or not, and see how that works. Okay, number 20. So number 20 made me really sad because my brother took the SAT in 1991 and I took the SAT in 1995, right after they changed the SAT. So I didn't do as well as he did, but this made me realize that I did a lot worse than he did comparatively to the standard score. But I will not reveal either one of our scores. Anyway, so the standard score for 500, so you have the standard deviation. This is just that same Z equals X minus the mean over sigma. So it'll be 500 minus the mean for the old SAT of 470 over the standard deviation of 110. And you're going to do that same idea with number 21. You're going to get the score for the 500 from number 20, and you're going to do the same thing with the standard deviation and the mean for 2009. And whoever has a higher standard deviation, a higher Z-score, will have done better comparatively to what the colleges are looking at. And that's it.